Hi guys, I'm your friend Humayun Malik and today we are going to discuss a mathematical technique which we will directly use in the derivation of our upcoming lectures, which is known as Stirling approximation. So in order to define Stirling approximation, let me give you an example. Let's suppose n is some number, and in first case I want you to take n is equal to 2. Then in order to find 2 factorial, you know that you should multiply 2 with 1, which is equal to 2, and it is very easy. Now in second case, I want you to take n is equal to 3. Then you know that in order to find 3 factorial, you should multiply 3 with 2, then with 1, which is equal to 6. Okay, now in third case, I want you to take n is equal to 4. Then in order to find 4 factorial, you know that you should multiply 4 with 3, then with 2, then with 1, which is equal to 24. Now what if I say that take n is equal to 100? Then you would say come on, and you know that things become boring or difficult or lengthy. So Stirling suggests a method for the case when n is very large. So now let's discuss what is meant by Stirling approximation, and we will at the end we will get Stirling formula. So according to Stirling, when n is very large, then n factorial becomes very large, and so commutation becomes quite a tedious process. So Stirling suggests a method to find log n factorial where n is very large in number. And as we know that n factorial is equal to n into n minus 1 into n minus 2 n minus 2 into n minus 3 and up to so on to 1. Or we can write it as n factorial is equal to 1, 2, 3 up to so on n. Now in next step we will take natural log on both sides. So left hand side will become log n factorial and right hand side will become log into whole term. And here we have used the property of log, that multiplication is converted into addition. So the right hand side will become log 1 plus log 2 up to so on log n minus 1 plus log n, which we can also write as summation x is equal to 1 to n log x, and we name this equation as equation 1. And now as we know that summation represents discrete sum, and on the other hand we know that integration represents continuous sum. So now in next step we replace summation with integration, and we will get log n factorial is equal to integration 1 to n log x dx. And now we will use integration by parts, which is that first as it is integration of second minus derivative of first into integration of second and whole integration over the x. And by simply integrating and putting limits, we will get n log n minus n minus 1. And as we know that n is very large, then if we subtract something, or we can say that if we subtract 1 from n, then it makes no difference, or we can say that n minus 1 is approximately equal to n. So our above relation will become log n factorial is equal to n log n minus n. And this is our required result, and this is known as Stirling formula, which we will directly use in the derivation of our upcoming lectures. So see you guys. Thank you.